Any John here? Thank you, John. Yes, so my name's Louie. I'm a staff engineer at Flagstone, same company that Daniel works at. And I normally cover like the front end systems like web and mobile. And today I'll talk to you about how to hack an NPM package. So let's begin. So yeah, a couple of disclaimers before I start. This is not an endorsement for hacking Bravo TV. So I'm going to talk about Bravo TV. I thought, especially since it's recorded, I want to make sure that's on the record. There will be JavaScript code as well. So if you're a back-end engineer, I'll give you a trigger warning when that happens. And I binge watched a reality TV show called Below Deck. Don't know if anyone's seen that. Hands up. Anyone seen that? No? It's mind-numbing TV. And it covers like staff who work on mega yachts. And yeah, if you want something to watch to like throw your life away, recommend watching Below Deck. That's me as a captain. NPM. So what is NPM? So NPM is the de facto package manager for Node.js runtime, and that covers effectively JavaScript-based applications. So, everyone's probably used it without knowing. So mobile apps, if you're using Meta or Facebook, they're going to be using React Native, which uses NPM packages. If you're using VS Code or Cursor, that uses Electron, which uses NPM packages. If you're, working on, I don't know if you see, Next.js, which is a backend framework, also uses Node, and IoT, it's ubiquitous really in the industry. And if we look at how many packages it's got, it's well more than 3 million now. So probably 4 to 5 million packages on the registry, used by 10, 20 million developers, with billions of downloads as well every week, making it pretty much the most popular package manager available. And yeah, in terms of what a package is, at its most basic level, it's just functionality that can be reused and put into different projects. So if we have a little look at what they all share in common, they all have something called a package JSON file, which is sort of like metadata about the package and used by consumers to be able to import these packages. So you start off with a name, which is like the name of the package that you bring in. You got your version, which is like semantically versioned packages. You've got your main field, which is just the scripts that gets pulled in when a consumer uses your application. You've got your dependencies. So these are dependencies that are used by the package to create the functionality. And you've got dev dependencies, which is used to bundle the scripts. So the thing that you see in main, you tend to use something like Webpack or some sort of bundling system to convert it from TypeScript, for example, to JavaScript so it can be consumed in the application. And then you've got scripts as well at the bottom. So this can be used when you're building the application locally. You're running tests. Also, you have these things called installation hooks, which I'll be talking to you about in a bit. And you've probably seen this meme as well, where you think you're importing one package, you end up installing like a million or something like that. And that's because in early days of NPM, there's not really a standard library for Node. So you end up getting this fractures of like different packages that provide different functionality. For example, accessing the file system and things like that. And as a result of that, there's just micro packages. So you've probably seen, is odd and is even being packages on the NPM registry. It's almost like a meme at this point. But yeah, what you do when you run something like npm install is can look at all these dependencies and then install them into a node modules folder. So you see here, you've got Lodash and then all the dependencies that exist within there. So if we sort of look at, NPM is sort of very much an open source project, really. It's open for anyone to be able to create a package. It could be an organization or an individual, and for it to be used by anyone as well. Very easy for this to happen. I don't know if anyone's created a package, maintains a package. Okay, well, what tends to happen is you'll create a package, as a side project, and then what will happen is that it starts to get traction. Companies start using it, individuals start using it, and then what happens is you feel really good for a bit. You've got 1,000 stars on GitHub, brilliant. And then what happens is start getting issues raised, you get feature requests, and there's just that expectation on you as a collaborator and the maintainer to actually keep it up to date, even though you're not getting paid for it. And I think this is a really good quote from the 2025 State of Open Conference, which says, much of the open source ecosystem relies on volunteers putting in too many hours for too little support, and the cracks are growing. And you've probably seen this meme as well on the right-hand side, where it's like all modern digital infrastructure, and there's just a random project that someone's created where everything depends on. And then if we look at some stats, this sort of like solidifies this understanding. So 60% of contributors aren't paid for open source work, and 58% have experienced burnout as well in the past. And if we juxtapose that with like some stats around like how many projects use open source, this comes from the Linux Foundation. More than 70% of app code is open source, and 90% of enterprises use it. So you can see where this tension sort of comes from. And as a result of that, you just have story after story of threat actors stealing credentials, hacking packages, being able to, especially with the rise of crypto. This is very much open season really for hacker groups and nation-backed hacker groups to. That's right. Nice. Nation-backed hacker is probably one of them. If there's a hacker group coming to see. So I think what's really important as well is sort of realizing just how bad this is for the ecosystem. So if we look at August 28th, which was only a couple of months ago, NX, which is a very popular monorepo management tool, was hacked. And as a result of that, leaked. What we do is it will be installed in your system, and then it will use something called TruffleHog. Probably everyone knows what that is. And just package up the contents and store it in a public repo. And then it got even worse on September 9th. Weird story as well. Whenever I do a talk, like 2 days before, there's a ridiculous hack that happens. So I did one around September 9th as well. Around 10 to 12 core packages that had a combined 2 billion weekly downloads was hit by a supply chain attack as well. And in this one, what they would do is rather than it being triggered through an install, it would actually bundle into the application and target crypto companies. So whenever the app code runs in the browser, it would actually swap out the wallet address for the threat actor's address to be able to harvest like Ripple. And then it got even worse. I'm sure everyone's seen this one as well. There's Shai Hulud's worm round one attack. So effectively what happened is there was this worm, probably people might know this from June. I think it's a worm in June as well. But what it allowed the threat actor to do is rather than hack one package, it would, whenever it was installed on a maintainer's machine, it would look for NPM tokens that existed on there, and it would find every single package that the maintainer had, republish it with the worm, and it just self-propagated. And you ended up getting over 500 packages that were hacked. They used the exact same sort of model of using TruffleHog to siphon credentials and then pass them up to a central server. And then a couple of days ago, and I think it's gone on still today, some of us probably reading from the effects of what Shai Hulud's round 2 has happened. So this is now affects over 800 repositories with billions of downloads. And it's a new variant where going so far as like rather than just siphoning credentials, like just rather than doing that, if it can't find any, it will just remove your package, delete the contents effectively. So against that backdrop, we're going to create a completely fictitious example. So obviously I was watching Below Deck, so Bravo TV make Below Deck. So they're hiding the new series of Below Deck behind a Premium Plus paywall. We're very angry, got nothing else to watch. So what we're going to do is we're going to hack the Bravo TV CMS and release the new series to everyone out of unfettered rage. So what is the plan? Obviously, it's really good to see Danielle's presentation because this is sort of almost an exercise in threat modeling. So we're going to research the company. We're going to find a package that NPM package that Bravo depend on. We're going to hack that package. We're going to somehow sweep CMS credentials from the developer's machine, and then we're going to release Below Deck to everyone. That sounds like a mad plan, but we can try it. So the first thing we want to do is research. So that I think, I don't know if you tend to see now, there's a lot of a drive to create developer blogs. Everyone wants to shout about what they want to do. And this is great. It's great for like personal portfolios and etc. like that, but it's very good for hackers as well because it gives you a glimpse into like the architecture of different organizations. So in this particular example, we can go to the Bravo TV CMS blog, to the Bravo TV dev blog, and we notice they share a post about using an open source CMS. Open source CMSs tend to have really great in-depth documentation, so we can put that in our back pocket when we create the hack. The other thing that we see is that they use a visual regression package from NPM. So if you don't know what visual regression is, there's something called visual regression testing. And what you do with that is you take, so for example, you've got a website, you take a screenshot of every page on the website, And then what you do is whenever someone makes a PR and changes the code, it will take those screenshots again and then compare the difference between them. It's quite a nice way of doing UI testing. So what we can do is we can look into that package from NPM and then look at their package JSON file and then try and figure out which of these dependencies are probably the easiest to hack. So this is obviously a supply chain attack that we're executing. So what we do is we create like a very, heuristic-based checklist on what we can use to rank these packages. So we can use something called Sneak Advisor, which is an open source tool that checks for package health. So look at things like, maintainability, how many contributors they've got, how many downloads there are, what are the security measures in place for the package. And that will give us a really good idea of what to hack. So we can see, small contributor base. We can look at the maintainer. If they've got a lot of packages, it's probably likely that they're sort of overworked. If it's got a lot of open issues, suggests maintainability issues. And if there's no formalized release process, so what you tend to get with more established pipelines, for example, with Lodash, you tie the CI/CD process to the package publishing process as well. So if they haven't got that, that shows it's a lot easier for us to execute on the hack. So what we're going to do, we're going to go through each one. As I mentioned, we've got Lodash, it's got 83 out of 100. Probably don't want to touch that. We're going to keep on going through, and then effectively we will see a package called Porthole. So what is Porthole? So it's a tool to compare two images for differences. So very much used in that visual regression space. And if we look at the performance on Sneak Advisor, you can see it's got a 36 out of 100, which is good for us. Lower the better. And then if we look at the maintainer, we can see they've got over 50 packages. Most packages haven't been updated, which shows a lack of concern really on the maintainer's part. And then they have a GitHub repo, but manually released on NPM. So like I said, there's no formalized release process, which is great for us. So what we can do then is figure out how we're going to execute this hack. So firstly, we're going to use social engineering to gain NPM publish rights for the package. And then second of all, we're going to add a malicious script to the package that can be released using the package access rights that we've got from the first step. So what we're going to do is we're going to use one of these three options to execute the hack. So phishing campaigns are incredibly successful, especially on NPM, because for two-factor authentication, they use time-based OTP, which means that if you send like an email to a maintainer that says, update your two-factor authentication, what that means is they can put in the password or passcode on a fake site, and then we can automatically use that to log in and get NPM publish rights. This was used in the last two, so the attack which caused 10 core packages to be hacked was done through a phishing campaign. You think it's so simple that you wouldn't fall for it, but it's very easy to. And as a result of that, they've NPM have revoked the ability to actually do one-time password anymore. They've now sort of leaned into like Fido and passkeys. So if we look at the fake tech interview, I think this is my favorite one. You might have seen this as well. So what's involved in here is, for example, Lazarus, the North Korean hacker group, they would pose as LinkedIn recruiters. They would ask open source maintainers on LinkedIn whether they wanted a job, obviously offer them lucrative salaries. They would end up doing a tech test, and that tech test would contain a malicious package that would then cipher the credentials on the candidates' machines. And then we're going to go for something called the VRP treatment, because I think there's no way of being able to guard against this, and that's just effectively hacking the person. So what will this involve? So it's going to get a bit dark, but what we're going to do is we're going to spam the repo with using sock puppet accounts, really trying to encourage burnout in the maintainer, because if they see a bunch of issues, there's no reason that, especially if they're maintaining so many other packages, they're not going to want to contribute at all. So what we're going to do then is swoop in as a hero and help out by responding with issues, updating documentation, responding to feature requests, and then effectively trying to get that package author's trust. And the final thing is like following the maintainer's socials, because you want to get a good understanding of when would be the right time to actually execute the hack by raising a PR when the author's busy, for example. So let's say we go through this process of months of gaining that trust, and then eventually we gain access. Now that sounds like a very short period, but this has been done time and time again, where you gain that package author's trust in order to get access to it. So now we've got access. We're going to wait for 4 months, and then we're going to figure out what we're going to do to execute the malicious payload. So this is what we want to try to achieve in terms of using that malicious script. So the developer is going to run npm on their machines. Somehow we want our code to be triggered straight away. And then what we're going to do is get our code to sweep environment variables matching the CMS auth token that we saw from the open source blog. And then what we want to do is forward that token to our server. So how do we achieve that? Well, very easily actually. So the majority of hacks that are done on npm use npm lifecycle scripts. So what that allows, any sub-package, so whenever a consumer runs npm install, you've got thousands of package installations that are also being installed. But any of those 1,000 packages can actually hook into the lifecycle of the installation, which means that we can run arbitrary code whenever our package is installed on the developer's machine. And as a result of that, it's very hard for the consumer to detect what was run by our package. There's a huge sort of vulnerability that npm has, and which is very easy to evade in terms of what we can do. So the second part is the malicious script that we want to execute. So we've got publish rights. We want our script can run. We know we can do that. So now it's all about evading, using evasion tactics. So what we're going to do, we know it's a visual regression package that we want to hack. So we want to tailor our hack to this visual regression package. So what we're going to do is use something called image steganography. So that involves embedding our code, our malicious code, into an image, so that when we do raise a PR, there's no way for the maintainer to see what the problem is. And then what we're going to do is figure out a way to get that code out of the image and then run it on the developer's machine. So how do we achieve that? So this is the JavaScript code. Very simple. We're not using like command and control or anything like that. All we're doing is we're getting a CMS token that the open source blog recommends, and then we're going to just very simply make a GET request with that token and send it up to our server. It's a very simplistic version of this. What you'd normally do is like encode it as much as possible to evade detection, but this is what the script basically does. And then we're just passing up the token as a query string to a server. So how do we embed that into an image? This is Captain Lee from Below Deck, and what this allows us to do is what we can do. Image is made of pixels. It's just an array, like buffer array, and it will just tell you the location of the pixel and then the color of the pixel. And if we look at a PNG pixel, the color can be represented as RGBA. That stands for red, green, blue, alpha. Alpha being the transparency, to control the transparency of the pixel. So if we look at this bit on Captain Lee's forehead, we can see that the red, green, blue, alpha can be any value between 0 to 255. 255 being solid for alpha. So what we can try and do is we can loop through this script, convert it to the UTF-16 code unit equivalent. So for example, C is 99, and then use that value to loop through every pixel in the image and just change the alpha value by the character code unit. So what we can eventually do as we go through this is we keep repeating this process until the code is completely embedded into the image. Then eventually what you see here is you've got two images, and then you've got the one on the right that actually has the embedded codes in it. And there's no way really for any sort of automated scanning to be able to detect that there's random code injected, because you would have to just do modulations on the alpha channel to figure out what the problem is. So now we've got the codes. Now we've got the image with the malicious code in it. We need to figure out a way of extracting that from the image, building up the script again, and executing it. So it's, again, it's a multi-dimensional array. So what we're doing is we're looping through each coordinate of the pixel, and then we're getting the alpha channel, and we're comparing it to see if it's not 255. So 255 is solid, so we know that if it's not 255, it's going to be the code that we've changed. And then what we're doing is we're building up that script again. And then finally, because we're using JavaScript, and it's, I clicked on the wrong thing. There we go. Because we're using JavaScript, a nice feature of dynamic languages is that we can just run arbitrary code in runtime. So we can use either new function or eval is like the more common one. And this just allows us to execute that script on the developer's machine. So the next part of this process is actually getting this code, through PR review. So this first PR is just an image that we're adding. Like no sort of like code that's been added. We just add in an image that can be used, effectively for testing if we wanted to say that. So we wrote that first PR that gets approved. Then we go through the second one. So the second PR is the PR with the post-install scripts. Because it's visual regression, it might have a post-install script already, but let's say we can just amend the script that's being called on post-install with the code that's decoding the image and running it. So if you think about it, these PRs by themselves shouldn't flag any sort of concern because they're completely disparate. There's no sort of effective like hacking in those scripts by themselves, but together that's where they really sort of pack a punch. So what we can do is we can raise these individually, and if we go back to the maintainer, they're not going to be that keen on sort of contributing to it, and we know that the contributor base is so small that it's likely we'll be able to get this PR through. So we get it through, great. Now we've got that, so we've merged in the code into the package. We've got npm publish rights. Now we see that previous version was 3.1.0. So what we're going to do is release 3 different versions. We're going to create a patch version, which is 3.1.1, minor version, which is 3.2.0 and 4. So why do we do that? Why do we go to that effort of creating multiple versions? Well, it's to cast the widest net in terms of packages that are consuming Oz. So if you think about semantic versioning, you've got on the left-hand side, you've got major, minor, patch. So what we can do is we know in npm, what developers will do is they'll provide different symbols at the start of a version to install like the latest version, for example. So if you use the tilde for 3.1.0, that's going to be everything greater in the same minor range. Then you've got the little top hat, which is everything before the major. And then you've got like the arrow as well, which is everything after 3, including major. So we're trying to cover the widest range of versions as possible. So now we wait. So the Bravo developer is going to run npm install in a project that uses the company's visual regression package. Because of supply chain attack, that's going to bring in our package, the hacked one. It's going to run that, and then it's going to run the post install on the developer's machine. It's going to bring in our codes. It's going to run on the machine, and it's going to siphon CMS credentials and send it up to our server. We notice after a couple of days that we're starting to get entries into our server log. So you see here, obviously this is, you tend to do like posts, obviously, to evade automated scanners, etc. But yeah, we can see it's running on developer machines, CI and production environments. And yeah, now we have that information and we've got the CMS token and it works. What we can do is look at the open source CMS blogs to figure out how to construct an API request, and then use that to enumerate the projects. So it could be like below deck, for example. And then we're going to set the flag to premium plus to true by doing a post request with our API token. We see that as premium plus, and we're going to set it to false so that it's available for everyone. And then eventually we have access to below deck and everyone can watch it for free. So obviously this is a really, it is a pretty contrived example of like what can be possible. But really the sort of takeaway is that you should never, it should be zero trust when it comes to including an npm package, because of how easy it is. And obviously it wouldn't be a talk without talking about AI. So, a lot of the stuff around creating a checklist and manually going through dev blogs can be easily done through deep research. So you've got tools like Claude, Anthropic's Claude, you've got Gemini, you've got ChatGPT 5.1. All these latest models have really effective capabilities when it comes to deep research. So for example, I know I tried it on our company. You could just ask what npm packages does Flagstone use, and it will completely do a checklist on which packages we use. We'll try and scrape as well different websites to figure out what packages you're using. And then you can pair that with the sort of checklist where it's ranking each package by its package health on Sneak Advisor. And within 5 to 10 minutes, you'll be able to access you'll be able to understand which package is probably the most vulnerable to use. And yeah, as part of this, it lowers the barrier of entry for hackers as well, because you can get ChatGPT or you can get Gemini to create the code. So if you don't know JavaScript, you can just get LLMs to be able to do that for you. And part of that is code reviews as well. I mean, you can use it for good by creating an agentic persona that will act as a security research and give you pointers on how to improve your code. That also goes the other way as well, where it can actually give you pointers on how to further obfuscate your code, how to evade detection from automated scanners. I just thought I'd throw that on in there. Yeah, so mitigation is just, be vigilant about the information we share about our tech stack. It's good to sort of shout about what we do, but also you need to use threat modeling to, especially in this sort of cases, like what parts of the architecture are we actually exposing to potential hackers? Ensuring that there's a due diligence process for assessing the package as well. Using Sneak Advisor to figure out, should we be using this package? What sort of attack surface does this open us up to by including this package? Do we need one? A lot of the times, these are micro packages that perform very small bits of functionality. We could actually, write that ourselves to prevent this problem from happening. And then using an NPM proxy, so you can use a tool like Verdacio. So rather than relying on the NPM registry, you actually create a proxy in between. Gives you a lot more control over what packages you want to be installed by developers. Another one is I think this is sort of a basic thing, always commit the package lock file. So what that not only allows you to do is create reproducible builds between local environment and CI and CD, but also, if you have a package lock file, if there are any 0 days that come in, it's going to use the lock file to install packages. Using ignore scripts, probably the most important one is. This would completely nullify the attack that I was talking about. And a lot of NPM hacks use this post-install. So what you can do is you can ignore any post-install scripts or any sort of pre-install or post-install script from executing. So you want to disable that install lifecycle. And then just because it's a new package version doesn't necessarily mean it's safer. With 0 days, it's a lot easier to introduce new vulnerabilities. So it's always best to have a bit of a backup time or a waiting time until you should be able to include that into your project. And probably my biggest recommendation, if you are doing JavaScript-based applications and you're using the NPM ecosystem, use PNPM as your package manager. So they provide multiple security benefits when you use PNPM. So one of them is a minimum release age. So you can say to PNPM, don't install any package that is less than a day old. That gives the automated scanners and security researchers enough time to raise 0 day incidents. It also gives you the ability to allow list any sub-dependencies that can run on post-install or pre-install. And also, what you can also do is there's a zero trust policy as well. So if the trust policy is deemed less than the next release, then that means that it won't install the package. So it's another beneficial part of that. And finally, I'm sure everyone knows this as well, integrate a software composition analysis tool in the dev lifecycle. You want to, make sure that you've got automated open source dependency vulnerability scanning and monitoring. Continuously analyze your SBOMs of applications to make sure that you're not introducing any vulnerabilities and you can be shown that there's issues. The static application security testing sort of that prevents any sort of code that's been maliciously bundled into your application. Dynamic application security testing as well is also very beneficial. So running your code and then continuously assessing at runtime what it's doing. Is it making calls to insecure endpoints that you weren't expecting? And finally, a really cool tool that Aikido provides, which is called SafeChain. It's in beta at the moment. What it allows you to do is it's a pre-install package scanner. So when you run npm install, what it does is it's going to look at all the packages that you're just about to install, compare it to a registry, and just prevent that installation if it finds a match. And I think that's everything. Yeah, so thank you for listening. Yeah, I do realise I probably went way over how long I was meant to, but okay. Cool, yeah, any questions? Well, Shai had sort of like left markers, didn't they, around like public GitHub repos and yeah, and then you tend to have, so for example, on AWS, you can get notified when a user is trying to request permissions to execute, and then it automatically gets scanned and picked up and get notifications as a result of that. So I guess there's also the ability to have, you probably should have automated scanners looking at what's being executed on a resource level. So indicate, so for example, if something's being run at 1, 2 in the morning, it's very unlikely that a developer is going to be well, maybe sometimes if they're dealing with an incident, but it's very unlikely they're going to be online at that time. So it can sort of look out for differences in the norm and be notified as a result of that. But yeah, in this case, to be honest, there's not much that you can do about it. The only sort of remedial actions is just ensuring that your infrastructure team are able to look at network requests and be able to assess, right, did we download this package? So for example, with the Shahid example, a good way to be able to counter that or be able to understand very quickly if you've been hacked would be looking at the public GitHub, but also comparing the list of packages that are known to have been hacked with network requests to see whether any developers installed that on their machine. And then I think you mentioned earlier as well, looking at the S-bombs and comparing it to known packages that have been installed. So yeah, having a tool that can do that scanning as well is incredibly useful. Yeah, it's like elevated access because you're running it within the terminal. I don't think they will, but I think the onus will be more. So, for example, PNPM are starting to provide defaults. I think they're going to announce in the next version that they're looking to delay by default installation of packages as a version. Yeah, exactly. Yeah, it's sort of like balancing it. So I think they want to try and introduce an opt-in or actually more of an opt-out because of the ramifications that we have. And I think it's just a flaw in the system design of NPM that has caused this. But yeah, I think all NPM can do on their side is just ensure that there's that sort of preventative measures in terms of how easy it is, because you just needed an NPM token, right, without an expiry before. But now they're starting to introduce, right, you need to make sure that you're using sort of like a tie between your CI/CD and your NPM sort of process to be able to link the two, rather than it just being arbitrarily run on the developer's machine. But in short, I don't think there is that. Yeah, or hoping that a package manager is going to like introduce the capabilities of being able to, because I think with PNPM they've gone a little bit far in that they can lock down which sub packages can execute. So it's by default it's going to ignore installation scripts from now on. So you have to opt in. I don't think that's on the books really at all with NPM. But I guess that's a good business plan, is actually creating a company where you can make it easy to control at the registry level which packages should be allowed in or automated scanning at that point. But yeah, if you compare I guess the difficulty is like, yeah, NPM is open source, well, same as NuGet, but I was going to say like you don't hear as many hacks executed on NuGet, but I think that's just purely because, yeah, as well as the scanning, automated scanning is a lot better and it's compiled, so it's a lot easier to figure out if there's any vulnerabilities. But yeah, when it comes to NPM, I think this is why you see so many solid hacks, especially with like self-propagating worms, because it is just so easy to create a hacked package and for it just to go haywire, because especially developers and organizations aren't really ready or prepared for this, because there's always just been that implicit trust on the package author rather than actually looking at who is the author, how can they be easily cajoled. No, thank you. No, it's good to hear your opinions.
We do have a question from the chat.
Oh, okay.
After that.
Yeah, go for it. Yeah.
It says, shouldn't source code review using tools such as Wiz detect these code vulnerabilities?
Yeah. That's a good point. Yeah, so there is like Sneak and Aikido provides automated, PR reviews as well. Actually, one of the Shai Hulud's repositories that was hacked, they introduced a vulnerability within the GitHub Action workflow, and there was actually analysis on the PR that said you shouldn't add this because of elevated access, and they still went through, and as a result, is a vulnerability, and it caused a lot of packages to be hacked. So yeah, adding automated scanning to your PR process, that's just a must, and you can do that with tools like Aikido and Sneak. I'm sure there are others as well, but they're sort of the core ones. Security recommendation, don't ignore it. Yeah. Cool. Yeah, exactly. Yeah. Just trying to think, what do I want to take down? Maybe something on Amazon or something like that just before Christmas. The record. Yeah. I'll let you know. Yeah. So yeah, that's Shah Hulud's second variant is still going. So I think at the moment there's almost around 800 packages that have been hacked. because they've added like a dead man switch effectively that says like if it can't access any public repos with, so what it does is when it attacks your package, it creates a GitHub repo using your credentials, and base64 all the credentials into a repo. If it can't detect that there are any public Shai-Hulud variants, it just completely destroys all your file system. So it's almost the onus is on GitHub and npm. So like if GitHub were to get rid of all the repos, that means they know it's going to invariably cost users to lose all their data. So it's just another, I was going to say, ingenious way of sort of making the hack pervasive. Because it tends to be what it also did is it would set your machine as a self-hosted runner as well. So yeah, just delete sort of like the home folder as a result of that, just to be extra pernicious. Yeah, is that so?
Right.
Yeah.
Are we